Come back to the channel. In the last video, we have discussed a bit about nucleophiles and electrophiles. In this video, we will start talking about the nucleophilic attack on carbon group. The first group which I have chosen is cyanide group. Addition of cyanide group on aldehyde and ketones. So if we start making a cyanide group, it would look like this. It have two lone pairs and a negative charge. One lone pair on nitrogen and other one on carbon. The main thing is that both the lone pair is in sp orbital, carbon sp orbital and nitrogen sp orbital. As carbon is less electronegative, its homo have more energy. That's why here the carbon actually donates electron to electrophile. Now let's suppose we have a carbonyl group. If we want to add cyanide, we can add it by adding NaCN with water as a solvent and HCl, which will be used for the protonation. In the first step, what happen? NaCN releases cyanide ion, and this cyanide, the carbon, donates electron to the pi star of this carbon group, which results in the cleavage of this pi bond, and oxygen get a negative charge. It would look like this. After this, the oxygen attacks on HCl and take the H plus acid base reaction. It results in the formation of this compound, which in general called as cyanohydrin. Okay, but there's a twist. This cyanide group is a good leaving group. Yes, this is a good leaving group. Because it is a good leaving group, this whole reaction is a reversible reaction. If you have noticed that this carbon is sp2 hybridized with the approximate bond angle of 120 degree. But here this carbon is sp3 hybridized with the approximate bond angle of 109 degree. I hope you could able to imagine that there is a decrease in the bond angle, which means this R group come closer to each other, and if they come closer to each other, it can be repulsion if these R groups are bulky, and hence this reaction is relatively more easy for the aldehydes, because in aldehyde one of the group here is just hydrogen, which is smaller one, and here it is hydrogen any aryl or alkyl group. Let's suppose if we just took the pH, this whole compound is benzaldehyde. When we just add NaCN and after protonation, we will get this compound. And if we just take a ketone, let's suppose this ketone, butane 2 on, and if we just add the same thing, NaCN with HCl, we will have again a cyanohydrine. But if we just talk about the equilibrium constant value, experimental value, this equilibrium constant value for the benzaldehyde is around 212, 212. But for this compound butane 2 on, it is just around 28. So uh, it means this reaction is more favorable for the aldehydes, not for the ketones. So this is the thing which we have, which I want to talk about. Important note is that the angle at which the cyanide or any nucleophile attacks to the carbonyl group, this angle by experimental comes around 107 degree. 107 degree. This angle is around 107 degree. Because if we just imagine that, let's suppose this is a pi star of carbonyl, then nucleophile homo will just attack here. Yes, it can happen because at the 90 degree we will see more overlapping. But in this criteria, in this situation, the lone pair of oxygen can repel more this nucleophile. That's why this nucleophile just shifts toward this side, and an angle of 105 take place. So this is just experimental value which I just wanted to share. Thank you for watching the video.